Welcome to the Data Hall YouTube channel. In today's video, we are going to talk about the Fama Macbeth regression that we use in finance and mostly in the asset pricing models researches. So now this was a technique that was introduced in 1973 by Fama and Macbeth. And what this technique does is it provides us the standard errors that are corrected for cross-sectional correlation. And it is also better when we have more cross-sections but less time series. And now we are not going to talk about more the theoretical stuff, but more into the applied side of how this technique would work. But before that, I'm going to specify the procedure that Fama Macbeth does, and then we would going to look into the manual way, that is by using the statsby command, and that would give us more clear idea of how this technique works. And then we would going to use this asreg command, which is a simpler way of working with Fama Macbeth regression. So let's understand the steps that are involved. So we have this step 0, where we perform a time series regression, right? So we have, let's just say, 10 firms, and within each firm we have 100 days of data. So in this case, we are going to perform a time series regression, and there would be 10 regressions because we have 10 different firms. For each firm, we would regress the portfolios. It is not necessary that we have firms, we can have portfolios. So portfolios or the firms return on the risk factor. So what are the factors in your specific research? So what you do is you regress the stock return on those risk factor and then obtain the regression coefficient. Remember, we would have 10, if we have 10 cross sections, then we would have 10 regression coefficients. So n number of regression coefficient is what we would get from this step 0. Then we have the first step, and there is a reason why I'm calling this step 0 and this step 1. We will discuss that in a while. We perform this cross-sectional regression. There would be T cross-sectional regression. And what does that mean is that we regress the portfolio or the stock returns on the regression coefficients that we have obtained from this step 0, right? So we have these regression coefficients. What we do is we now merge our stock return data with these regression coefficient data. And so for each firm, we would place the relevant regression coefficient, right? So we have a regression coefficient for each firm. And then we will perform a time series, cross-sectional regression on each day. So we have 100 days, and that we would have 100 regressions. So from these 100 regressions, time series, cross-sectional regressions, we would get coefficients. What we do is, the second step is we average these coefficients or perform the mean comparison t-test, and that would be the end of Fama Macbeth. Now, the reason why I'm calling this step 0 is because this is not the specifically part of Fama Macbeth regression. Fama Macbeth regression contains 2 steps. That is why it is called 2-pass or 2-step procedure. The first step is cross-sectional regression. The second step is to average those coefficients. Now, it is understood that we do have to perform this step 0, right? But for the sake of simplicity, I would call this step 0, and I have included that in our lecture. And how do we perform this? So all the packages that perform Fama Macbeth in Stata, they are just going to perform these 2 steps. And they would assume that you have already performed this step. Okay, so remember that Fama Macbeth's regression cannot be used when we have cross-sectionally invariant variable. That means that let's just say if we have GDP or inflation, so those inflation, if we have all the firms from US and we are regressing them in on the US GDP, then US GDP does not vary from one firm to another firm. So that is cross-sectionally invariant variable. And when we introduce that, remember we are performing this cross-sectional regression on different factors. So if we have a variable that does not vary with the cross-section, then those variables would be omitted. So we cannot perform this Fama Macbeth regression when we have cross-sectionally invariant variable. So let's start with the manual way. The idea of this manual way, obviously you would not perform it in your regression analysis, but the idea is that we understand this methodology in more clear way. So let's import this data. So I have different firms and we have their stock return for different days. So this is a daily data. We have their market, SMB and HML. These are the three risk factors that we are considering, and we have different stocks over here. Okay, so what we are going to do is the step 0 was to perform time series regression. So we use this statsby command, and if you are not familiar with statsby command, we have a video that explains the statsby command in detail. So you can go back to our channel and check out this video. So what we are going to do is we are going to perform this regression where we regress stock return on these three factors. And we are going to do that for each symbol separately. So when we do that for each symbol separately, let me just sort this on symbol and date. And what we are going to do is we are going to regress, where this first symbol ends, right? So we are going to take just this data for the Apple, regress RI on these three factors just for Apple, and that would become a time series regression, right? So we are going to do that for each symbol separately. And what this statsby would do is it would help us in getting those coefficients. So each time when we execute this regression, it would save those coefficients in a single file called step 0, right? So let me execute that. It would be executed quickly. And this is the step 0 file, and this is how it would look like. So we have 6 symbols, and we have got our regression coefficients for each of the firm, right? So what we are going to do next is that we are going to merge those coefficients with our current data, right? So we are going to use this merge command. Again, if you're not aware of this merge command, go back and check out the merge command on our channel. So now we have this Apple firm, and we are going to regress this. So let me just sort this by date. And now we are going to perform this second regression, which was this cross-sectional regression, which was a step 1, right? Oops. Okay. So let me comment that out. So this would be a cross-sectional regression. And again, what we are going to do is we are going to regress by date. So we are going to perform this analysis, this regression for each date separately, right? So we have 6 firms. So it would take this data, regress this RI, this specific data on these 3 coefficients, right? So now we are not going to regress them on these factors, but their coefficients that we have derived in the step 0 part. And this would become a cross-sectional regression because we just have cross-sections. So we are going to perform this for each period separately. And if we have 100 time periods, then we would have 100 cross-sectional regressions. See how we are going to regress RI on those coefficients and not on the original factors. So that is going to take a while. And once we are done with that, it would create a file by the name of step 1. Because I'm calling this step 1 because remember, Fama Macbeth have 2 steps, and the first step is to perform cross-sectional regression. Okay, so that is done, and let me just, so I'm not going to need this data, so I'm just going to import the step 1 file that we have just created. And so we have a regression coefficient for each time period, right? This date doesn't look readable, but if we just format this using format date into TD, and I hope that would work. And now we get a single coefficient for each date. So the second step, as per Fama Macbeth, is to average these coefficients, right? That is the step 2. So let me comment that out. So how do we average that? We perform the t-test, and we can do that by clicking over statistics and then going to classical test hypothesis and then doing mean comparison. One sample t-test, we select the variable, and then the hypothesized mean would be 0. If we click OK, and then that would run the regression. We get the mean value, but what we are interested in is the t-value or the p-value. And what that says is that this is not statistically significant. Now, you don't need to worry about the statistical significance at this stage, because I haven't taken a lot of forms. I have just 6 forms in my data, and you're going to have a lot of those forms. So just understand how this would work. Obviously, I'm going to perform the rest of the coefficients t-test, and we know that in our case, all these are insignificant, right? For them to be significant, the p-value should be less than 0.05. So you have understood the methodology, that how does this work. So let's use this simple method, and that is using the asreg command. Again, I have a whole set of video on asreg command, and this asreg command is also used for rolling regression. So if you want to perform rolling regression, then you can use asreg command. So first, this command needs to be installed using ssc install and then asreg, because this is a user written command. Let's again import the data, and for this command to work, we have to xtset, and that is to tell Stata that this is a panel data and we have a symbol and the date variable. Now again, first step should also always be, first we need to do the step 0, that is the time series regression. And this step is easy using asreg. So what we do is, for each symbol, we are going to perform a regression. Asreg by default does the OLS regression. So we are going to perform the regression of Ri on these 3 factors, right? And that would not save a file, but rather these coefficients would appear over here. So if we look at those coefficients, we have these coefficients, right? So again, manually what we did is we calculated that and then merged it to our master file, but with asreg we do not need to do that. Next, I'm going to perform the first step 1 and the step 2 in a single command, because this asreg, what we do is we specify the stock returns and then the coefficients that we have estimated, right? And then we are going to use this option which says FMB, and this stands for Fama Macbeth Regression. And if you do the help of asreg, and if I can scroll to the option where it discusses about the Fama Macbeth regression, it says that the first step involves the n cross-sectional regression, the second step involves the time series averages. So this is why we need to perform the step 0 by ourselves. But remember, because when we are going to execute this command, it is going to say that this r square is already created. So what we just do is drop the r square and adjusted r square and then execute this command. So it is going to perform this Fama Macbeth regression. And if you just want to compare this with the previous results, So I have taken the screenshot of that, and let me go back where I have used this manual t-test. So this should be exactly similar to these results, right? So we get the mean value, right? That is the same. We get the exactly same standard error. We get the exactly same t-value. Obviously that is rounded to 2 decimal digits, and we get exactly same p-value. The same goes for the SMB and for the other factors. So this asreg command does the exactly same methodology as we did previously. So again, if you want to save the results from the first stage, I mean step 1, but because this asreg with this FMB option is just going to perform the step 1 and 2 combined. But if you wanted to save those results, you can use this first option, and that would display those in our Stata's result window. Or if you wanted to save that, you can save that using this save option, right? So that will just save the step 1, but normally we do not need that. Okay, let me just sort this on date, right? And now remember, most of the people that I have seen is that what they do is that instead of performing this step 0 and then using the coefficient in the next step with the FMB option, what they do is they directly use asreg command, write the name of the stock returns command, and then specify the coefficients with the FMB option. Now what that is going to do is let me just drop these first, and then let me explain this. Okay, what that is going to do is it is going to omit all these variables, because when you are going to use FMB option, what it is going to do is it is going to take this specific cross section, because first step of the FMB option would be to use the cross-sectional regression. And what you see is there are the same values. There isn't any variation, and when there isn't any variation, then obviously those variables would be omitted. They aren't variable, they are constant then. Okay, the last option with this asreg command is we can also have Newey-West adjusted standard errors, and that is used to correct time series autocorrelation. The simple option that we can use is use Newey, that stands for Newey-West, and specify the lags that we want to have. And the command would work the same way, and the regression results would obviously be the same. But let me just first execute this step so we can have those coefficients, and then I can use this Newey-West. R square is already created. Let me drop those. Okay, so now that would work, and it says that Newey-West adjusted standard error using 2 lags. You can have any number of lags, but that should be an integer. Now lastly, there was an older command that was called xtfmb. Now I won't suggest using xtfmb because asreg is quite faster, but this is just to give you an idea, because if you are familiar with xtfmb and you are worried that what is the difference between asreg and xtfmb, so that would this part would help you with that. So let's import this again, the original copy of this data set, do the xt set, and again perform the step 0 because that is what we need to perform. But I'm doing that using statsby. Okay, so this file already exists, so let me just use the replace option. Okay, now I'm going to merge it with our original data, and now we are going to use the xtfmb. Remember, it is a user written command, so you'd have to install it. I specify the stock return and then the name of these variables, but there is one issue. You might face an error with this setting. Okay, so the error that we are getting is that this variable is not found. Now, I already knew that we would get this error because it took me quite a while to figure out why I'm getting this error, right? And there is this some kind of a bug in this xtfmb. What we need to do is we need to drop these variables. The reason is that it cannot accept anything with an underscore, starting with an underscore. So I'm just going to rename all these variables without having them an underscore, right? So this would become mkt, then we would have smb and html, right? And now if I execute this command without these underscores, right, that should work. So that had been executed. Now I had paused the video and it took quite a while. So this is a slower command as compared to asreg, but just compare the results with the ones that you are getting with the xtfmb, and they are again exactly the same. So whether you use xtfmb, the manual method, or the asreg method, they all produce the same results. So thanks for watching this video and stay tuned to this channel for more Stata related videos.